Hi, this is Dr. Mood. Welcome to our lab. We're going to be separating a complex mixture.
Yep, this is going to be using physical and chemical means to separate a complex mixture.
So in this lab, we're going to have a mixture that has sand, calcium carbonate, as well as some salt. And we're ultimately going to want to figure out what the percentages are of each of those in our mixture. And we're using mixture C. And so we're going to be using various chemical physical separation techniques to identify the percentages of all of these.
Yeah, so we're going to start off by just weighing our sample, getting a set amount of our unknown. Again, that's unknown C. Make sure you make note of that.
And remember, when you're using a balance, always remember you want to zero it out. It's also called tairing. And just make sure before you add any of your chemicals, the balance says 0. So all the mass you see is coming from the sample that you added.
You'll see with our scales, we can actually pull back the doors on both sides so we can get full access onto the scale.
And the reason we have these doors, but when you start getting out to that third, fourth decimal place, the air conditioning, the ventilation in the room can actually kind of affect the mass because the air pushes a little bit of force on it. And so you really need those doors. So we also masked our Erlenmeyer flask before we added any of our mixture and after, so that we can subtract those masses to also get our mass of our mixture. All right, so we're going to be adding water to our mixture. So again, we have salt, sand, calcium carbonate. Salt easily dissolves in water, as I'm sure you know, but the other two components won't. So whatever is dissolved in the water will just be the salt. And we're going to mix it up for a while just to make sure it all dissolves.
We sped it up a little bit for you guys.
It'll be a little hard to see when it all dissolves just because the calcium carbonate and sand aren't dissolving. So we did a little extra time just to make sure. So now we're going to mass a empty beaker. And this beaker is ultimately going to have our salt in it. And so once it fills up with the salt, we can subtract those masses to get the mass of the salt.
So we actually have different kinds of filter paper we can use for filtration. We actually want our porosity to be medium and our flow rate to be slow. This gets us a better filter. The way we're going to do this is we're going to fold it in half. So this is how you'd set up a filter. Fold it in half. Fold it in half again. But this time you'll see I'll offset the fold a little bit like that. So I have a little bit of an overhang on the top. And then your final step is you're just going to tear off that extra piece right there. The reason you do this, the fold this way and tear off the extra part, it just makes the cone a little bit wider and it fits the filter better, so you have more surface area of the paper touching the filter. Therefore, you just get a cleaner and faster and better filtration. Nice. All right, we're going to want to get the weight of this paper. That way, once we get a filter out of it, dry it off, we can get a mass of whatever's on top of the filter paper. And this will become clear later when we show you when we actually do it.
So here is our funnel. We're going to put our filter paper in the funnel. So we're going to put our solution through that. Again, the salt is dissolved in the water. So as the water goes down, the salt will come with it. And our calcium carbonate as well as our sand will stay in that filter paper. You'll notice I kind of wetted it before we add anything. That just kind of gives a nice seal before we add our actual solution. And this filtering can take some time also because you don't want to add it too fast. It can splash, it can spill, you can overflow it. And because we have the flow rate slower, so none of the calcium carbonate or sand goes through, it also is going to make it take longer. But even though it takes longer, it'll give us better data and results, which is what we care about more.
And lucky for you guys, we can speed this up so you don't have to watch through all of it like we had to.
In retrospect, I should have got a ring stand, but
That way you wouldn't have to hold it with your hand, but
yeah, what can you do now?
we like it, the dedication. All right, so you'll see every time we're about to pour more of the solution into the filter, we kind of give it a swirl. We want to get a nice slurry. We want to make sure all of our little particles and everything that's in solution is nice and mixed up and not being stuck to the glass.
You also notice when I'm pouring the solution, I put that stirring rod. So you're actually pouring onto the stirring rod. That's called decanting. It just kind of helps all of the liquid get into the funnel instead of spilling some of it on the side of the flask while you're pouring.
Oh, and I think I see some sand, or whatever looks like sand.
It's probably sand.
Looks like sand, smells like sand.
So, and then we're also just going to rinse it off with some water at the very end just to make sure all of our salt goes into our beaker. And so now that beaker that we previously weighed, that you should have noted the mass, now it just has water and salt. So if we find some way to remove the water and keep the salt, we could get the mass of just the salt.
Easy enough. So you can see this is taking a very long time.
And as you have less liquid pushing on the top, it takes even longer. You could do some calculus if you wanted to,
But we don't want to.
we don't need to.
No.
So.
Okay, as Dr. Mood's arm is getting very tired from holding this filter for so long, we're reaching the end of the process. Okay, got to switch arms there.
So now we're going to evaporate all of the water that is in the beaker and just leaving over the salt. So then once the water is gone, we can take the mass of just the salt and the beaker. We already know the mass of the beaker without salt. You subtract those two and you just get the mass of the salt.
And this piece of equipment that we've placed it on is called a hot plate. Pretty cool thing. On the left-hand side, you see the dial that can control the heat. On the right-hand side, we have a stirring function. So there's a little magnetic part of this piece of equipment that if you put a magnetic stirring bar into your solution and turn that up, it'll spin and stir the solution, which is pretty nice. So you can get a nice even heating. In this case, we don't really care about that. We're just boiling off some water. So we don't need a stir. We can just use heat. And just a little quick fast forward. We've boiled off almost all of the water.
And so we're going to actually put it in a 100-degree oven to get the water to come off a little slower. If you leave it on the hot plate when almost all the water is gone, you can actually kind of have a reaction happen with the salt and the air, which we don't want to happen if you get it hot enough. So this kind of slowly lets the water off. It's obviously a time lapse. And so now our beaker just has salt and a beaker.
All right, so we're going to take the mass of it twice. We'll take it for the first time. The way you'll figure out how much is in there is you'll do the difference, right? Whatever the beaker weighed by itself, and the difference between this new mass. But then we're actually going to put it back in the oven just to make sure that it's completely dry. And you'll see. We'll take it, we'll put it back in the oven, we'll weigh it again. And if it got a little bit lighter, that means it was still a little bit wet. So we actually got the rest of the water off. So this is just a good way to make sure to double check your work and get rid of some error. Okay, here we go. We're going to go take the weight one more time.
We let it cool down a little bit first just so we don't damage the balance at all. They're pretty expensive.
Mm-hmm. All right, and you can see it's a little bit lighter, so we did boil off a little bit more water, or dry off.
So now we have that filter paper, so it has sand and the calcium carbonate. And so when we add this hydrochloric acid, the calcium carbonate will react with the hydrochloric acid. You'll see some carbon dioxide bubbling off. But more importantly, the calcium is going to go through and dissolve in the water and be in the water that goes through the funnel. And it's going to be calcium ions. See those bubbles? It's actually, this reaction is very similar to making those volcanoes you used to make back in middle school. When you mix vinegar and baking soda, there's this CO3 2- ion that actually gets converted into carbon dioxide, which is the bubbles you're seeing. It's the same ion that's in baking soda as well as calcium carbonate, called the carbonate ion. And we wash it with just a little bit of water to make sure, again, we get all that calcium ion into the actual water. And later we're going to precipitate it with some carbonate ion to make calcium carbonate again so we can get the mass of the calcium carbonate. It's nice this time I didn't have to hold it.
Getting smarter.
And just a reminder, we weighed this piece of filter paper before. And so now it just has sand on it. So if we know the mass of our filter paper, if you know the mass of the filter paper plus the sand, you can subtract those two to just get the mass of the sand. But before we go mass it, we actually need to put it in the oven to remove all the water. Because if we weighed it with the water also, we would get a very big error because water does weigh something.
And one thing you do have to be wary of when you're drying filter paper like this, you don't want to burn it. And you can see we crisped it a little bit, and that's okay, but you definitely don't want to burn it to the point where you have holes in it or you're missing some of the filter paper because, again, that's going to throw off your results.
Yeah. Even having that little bit of charring, it will lead a little bit of error, but you should still get really good data. So again, we always hit that little tare button in the middle. It makes it 0.
Filter paper is kind of making me think of like a velociraptor, you know? They have around their neck. No, just me?
I think that's just you.
Okay, I just watched Jurassic Park. Oh.
Almost. So now we just have our solution that has the calcium in it. It's also a little bit acidic because we added the HCl. We're going to add some sodium carbonate. And so that carbonate's going to combine with the calcium to reform calcium carbonate. And so we'll show you the calcium's still there. It didn't go anywhere. It just dissolved in the water. And you'll learn about these things more in the second semester of Gen Chem. But there's some amount of ion that you add to a positive ion that will cause it to precipitate. But you'll learn about all the mathematical relationships in the second semester.
In due time.
If you really want to know about it now, you can just Google KSP.
Or yeah, just ask Professor Schultz. Send him an email very late at night.
So you can see we're adding the sodium carbonate. You can see it's forming bubbles, and you're also seeing a little bit of precipitate there. So what's going on is the carbonate and the sodium carbonate is getting converted into carbon dioxide. And in the solution, there's some localized pockets where the carbonate concentration is high, and that's causing it to precipitate with calcium. But then as diffusion happens, the calcium carbonate redissolves because all of the carbonate will react with the acid that's still there. And so we have to add enough calcium carbonate, we have to add enough sodium carbonate to get rid of all the acid. And once we've done that, the carbonate ion won't react with anything else except combine with the calcium. And if we add excess sodium carbonate, that's totally okay because we're just going to rinse it off anyways, because sodium carbonate is soluble in water. And when you guys get to the precipitation rules, generally sodium ions are pretty much soluble with everything. Oh, hey, redissolved. So again, it redissolved because we have a more equal distribution of the acid in our solution. And so if we swirl it and it stays a precipitate, we know we've added enough sodium carbonate, which it appears we've pretty much done that. But we'll add a little bit extra just to make sure. So we're going to mass a different piece of filter paper because our calcium carbonate that we just reformed is going to get on there, and we'll dry it off again in the oven just like before. And so our filter paper will just have calcium carbonate and the filter paper, you know, the mass of the filter paper, you subtract, then you just have the mass of calcium carbonate.
Perfect. And again, this time we're using a Erlenmeyer flask to hold the funnel, so we don't have to hold it with our hands. And you can see there's that kind of like swirling around to get a nice slurry. And then we'll decant it in.
Yeah, you can see the precipitate kind of clumps at the bottom. You might be able to see it a little bit while we're pouring. And so we'll have to rinse it with lots of water just to make sure we get all the precipitate out. Because while the precipitate doesn't dissolve in water, just imagine if you had rocks in a bucket, if you swirl the bucket, the rocks will move too. I think that's a good analogy.
That's perfect. Yeah, leave a comment on this video if you ever had rocks in a bucket that you've tried to get out with water.
I don't know if I have, but you could do it.
You could.
So we're just making absolutely sure we got rid of all that. Well, not rid of, but washed all the calcium carbonate in. We'll let it slowly go down.
And you can see it, the liquid level dropping through the filter. This is sped up, of course.
We'll wash it a little bit because we don't want any sodium carbonate that happened to be left over to be on there. So we'll wash it off with water because we just want the mass of that calcium carbonate. So we'll do the same thing we did for the sand. We'll dry it off, and then we'll take a mass of it. 2 masses.
Great. I love it.
And if you ever use one of these ovens, always be very careful. It's at the boiling point of water, which is 100 degrees Celsius. Just want to take the same precautions as if you're dealing with boiling water.
And this time we did a little bit better of job of not really burning or crisping our filter paper.
So there's a learning curve.
There is a learning curve.
So I folded it up a little bit just to make it easier to mask. Doing it a second time.
Remember, we put it back in the oven. We didn't show you this. We dried it again. And you can see we lost a little bit of mass, so it was still a little wet. So use that last value.
All right, hopefully you enjoyed that video. We'll see you guys at the next video. If you have any questions, just ask Steve Stoltz.
Yep, through email at any time of the day, as often as you want.